Ed, I will be using 2 instances of the same program just because it's easier to record. And so this will be the server on the left, and then I also have a video of it on 2 different machines also. And so first, when it starts off, it queries for a server, and if there's none, it creates it. And so this will be the client. And then it queries for a server, and if it found it, it'll connect. Alright, so this is the client, and so only the server can go to the main game. And so the green ship here is the server, and it fires missiles and rotates and moves. And then you can only control the green ship, and this one can control, the client controls the blue ship, you can fire, and then also lay mines. So this one lay mines also. And so how it's set up, the client sends inputs to the server, and the server collects its own inputs and then basically puts it in through the simulation. So the server simulates the physics, and then the server will then output back the collisions and the and then the physics data, so like the X and Y positions, back to the client, and then it will, both games will then paint the screen and stay in sync. And so the client has its own ID, and then the server has its own ID. So when game objects are created, it goes through the list and finds them, and then it can destroy them or move them and update them as such. And so once the player wins, so player 2 wins, and then only it goes to the wins game over screen, and only the server can then go back to the lobby. And also, and then you can restart and play again. And then I think sometimes since I'm recording, it's lagging a little bit with the bullets and the collisions are moving past with the update. And yeah, so that's that. And so basically my game starts off with the update. You get you calculate the elapsed time, it updates the keys, this is both client and server, you process them, and then you're going to output them. And so if you're the client, you're going to output them back to the server. And if you're the server, you're only going to output the creation of missiles and mines. And so it sends data to the client and also to the server, and then they both receive them. Or just the server will receive the inputs, and then they process them, and then you simulate, the server simulates the physics, and then this is where you create, the game objects get the physics data, so like the positioning from the simulation. And then also when you simulate the physics, it creates collision data that gets sent, and then you output them back to the client, and then the client's going to receive them, and then they'll both process the input and then the removal. And so my input queue, all it does, so I have a queue manager that handles both the input and the output. There you are. So it's going to have an input queue and an output queue. And so the input queue processes each header. And so where the serialization of data happens, it's in my network manager. And so when you send data over, you output simulations or inputs. That's where it's going to serialize it. And so it's going to write the header, and then this is a client writing ship data. And so it's going to write it to the buffer and then send it out. And so then there's the output queue. So basically, when you run the output queue, you're either outputting inputs or simulations and data. And so if you're the server, you just need to output the mines and the missiles. So if it's a missile or a mine, and then if you're the client, you need to output all your inputs. And so usually when it you output, it's going to send it over the network and then add it to the input queue. And so I only have one output queue. And then how it's communicated is all through the network manager. When you send inputs, you go send them, and then you go send the message, and then when you receive them, so this is a client receiving messages. It's going to receive the data type, read the header, and then it's, depending on the header, it's going to say if it's collision data, physics data, ship data, or game state data. Read the specific one, attach it to the header, and then add it to the input queue. And so with the lobby, I showed that you can't move forward to the game unless you're connected. And so and only the server can go ahead and change the state. And so you can only move forward when you're connected. So if I ran the server, so first hit queries, and then if none are found, then you're the server, but you can't go forward because you're not connected. And So how I do it is I first have that query for the server. So basically it sets up a temporary net client and goes ahead and binds itself, and then it has a certain amount of tries to query, so then it discovers local pairs. And then if it doesn't receive a discovery response, it's going to keep track of the time between queries, and then if that happens, it's going to try again to discover local peers and go back for how many times you want it to try. And then finally, if it doesn't find anything, it's going to create the server. And so it shuts down this socket, and then it creates the server socket at the server port. But if it does receive a discovery response, it's going to go ahead and create the client, which is going to shut that down, create a new client, and then it's going to go ahead and connect to that server. And so the type of data, so I have the data header, which is what the input queues and output queues are. And so it has an output sequence number, input sequence number, the header type, which is ship, collision, physics, or game state, and then the data that it's set to. And so to control the ships, it's all under ship data. And so you have the functions. You can either move, rotate, fire, or lay a mine. And so if it's going to be move or rotate, you also have the axis movement in there. So then that input queue is going to go ahead and deserialize it. The ship will go ahead and when you receive it, it'll deserialize it and then create a new data header and add that to the input queue. And so when bombs are made, it's going to be a missile fire or a mine lay, and then when missiles are made, it's going to be missile fire. And so the input queues will process them and create their own object with that ID though, so then that specific ID is added to the game object list. And so the collision data just has the IDs of both of the collidable objects, and then all it does is say A except B, because it's in order. And the physics data has the ID of it, the X, Y position, and the angle that's set. And the game state data will have the game state, and if it's the add point, it'll add which gamer index you add the point to. And so how I differentiate between server and client is I use a strategy pattern. So when the server gets created, so the first state is the query state, and it goes through and queries like I showed you. And so then if a server is created, it's going to create that. And so they have differences, and then they also have specific IDs also. So you can identify which game objects to send over and which to also keep local, or which to only send over, which to do both. Yeah, and so when a server is created, it's going to be this state, and so it goes through the same loop, but when it's depending on the network state, so like this will only be the server side, which will simulate the physics. Until then a server is created when the server starts, or it's created, and if it's a client, the client will be created. Alright, I think that's everything. Alright.